I'm aware like we have this data management exposure to the data management platforms and day after tomorrow. But Jim Pollock is here, and we thought like why not we take that opportunity. He can share the experiences of aWhere, what we are doing. And I can briefly tell about this one. I think 3 days or 4 days before, we organized a data management capacity building program on data management platforms. And we have focused on a couple of data management platforms. aWhere is one of them. And what we will be doing, like we have 2 big projects that's being funded by the Gates Foundation. And the idea of how we can make the data available to the global community as well as in-house people also. That's essentially like an open access to data. So that's where like maybe they are bringing a platform which actually document the baseline surveys as well as the impact surveys to see what kind of impacts we have created based on our interventions both in Asia and sub-Saharan Africa. Jim Pollock is here. He's been working with us from last more than a year. We have started this journey. This was not that easy because they are technocrats, and here most of the individuals are the subject matter experts. The levels never be matched because when you need to develop a technology platform. But we are there to act like an intermediaries. We've overcome all the challenges. We launched this platform 4 days before, and we are ready to go. In the similar way, we invited partner organizations also. There was a quite good encouragement and very good feedback, and they wanted to utilize this platform into their research projects also. So what Jim offered after seeing all this excitement, they would like to extend free licenses, whoever interested, during that particular capacity building program. And that's routed through ICRISAT. I thought why not he provide an exposure to what they are doing and also share their experiences to see if you find that's relevant and would be useful. Still, you are encouraged to explore the possible opportunities to utilize some of these platforms in your research projects. Jim Pollock is Vice President in the vertical market development of aWhere from United States. In fact, it was a very, very short notice for him. We made him to behave like a James Bond to get visa in 3 to 4 days time by sending special UN letters, but he made it possible. He went to the embassy, collected the visa, he came back, he visited us just in a day or 2 days time, Jim. But he is very happy. One is he organized a beautiful program, and he also roamed around Hyderabad a little bit. He understood that Hyderabad is a city for the poles as well as the biryani as well. He got good pole set for his wife, and he's pretty excited. He's going to have a very good Christmas.
Yes.
With that brief introduction, Jim, the floor is yours. Please share your experiences.
Okay. Well, thank you for having me up here. And I'm also very excited that the way my trip, I was primarily here for the workshop last week for a couple of days to do a little more extensive training to the group last week. But it worked out since I'm here an extra day or two because I wanted to make sure I had time to go get some pearls for my wife. That was able to arrange, Chuka has shifted the schedule slightly, so I get a chance to actually address you and give you just a little overview of our platform. So I'm very happy that I was able to stay a little longer and get to do that with you. So, and I've enjoyed meeting several of you in some of the social sessions in the last day or two. So I'm with aWhere Incorporated. We're a software company in the United States. We have a big office in Denver, Colorado, where I stay. Where it's very cold this week. It's minus 25 degrees C. So I have nothing warm to wear, so it'll be very cold when I get out of the airport in 2 days. And then we also have an engineering office in North Carolina on the east coast of the U.S., where we do a lot of our software development for this platform. So, so what we have and what we've developed that we're working with ICRISAT on is it's what we call our aWhere platform. And what it is a location intelligent monitoring and evaluation data management platform. So it's a software system that is designed to manage data that is very strong in location information and also time-based information. And so we've built this platform on some industry standards. We're using Microsoft SQL Server as the engine underneath for the database itself. However, we've optimized the design of the database for events that are location and time based. It's very important, which means we're very focused. Like many of you have heard the term business intelligence, and there are many business intelligence systems developed by Oracle and IBM and other very large software corporations that are intended to work in almost any aspect of business, to run your financials, to run logistics, shipping departments, CRM systems to manage customer information. So there are general purpose business systems to handle many different types of data. We have a BI type system, business intelligence system, but it's completely aimed at agricultural applications. So we do not worry about financial information, logistics, etc. It's only focused on agriculture, which means we can really get it more specialized and sort of understands more terms. If you import a spreadsheet into Excel, for example, Excel will ask you what kind of data is each column, and you identify, you can say just a general term, you figure it out, or you tell it it's a date, or it's numeric, or a text. That's all it understands, date, numeric, and text. For us, we know date, numeric, text, but also yield, production, distance, so many of the different data types. We specialize in the data types because if we know that a column is production, if we add these things together and aggregate data up, we know that we can add those together. We can add productions together. However, if it's a yield, kilograms per hectare, we don't add those up. It doesn't make sense to add yields. You want to average them together. So we try to be very specific about the types of data and be smart about handling it so we don't get into a lot of error conditions that you can with just open, using Excel, for example. So, and there's two, primarily in our area, there's two kinds of databases out there. There's relational databases that you've heard of, again, your Oracles, SQL servers, relational database. There are also GIS tools, geographic information systems, but the relational databases are very good at transactions and very good at time-based information. They're generally very poor at handling location. Conversely, GIS systems like ESRI is a mapping tool. It's a very, very good tool and powerful tool for geography. It's very good at handling geographic data, but very poor at time-based information. So we've optimized our system to handle both location and time. So every single cell that we import, we assign a location and a time to it, which means it's easy for us to find other data sets and pull the location and time for the same place. So the idea is if you take a map of Africa and Asia and throw a dart, wherever it lands, we can pull any kind of information. We can pull weather information for the last decade, potentially soil types, if there's any farmer surveys, what kind of yields they had and experiences they've had. So any information that's come from many databases we can pull together for wherever that dart lands on the map. So we're optimized for things that are location and time based and really focused on agriculture, and in the future we've already done some work in public health area because it's so related to agriculture. And also we're doing a lot of work with the Bill and Melinda Gates Foundation because their problem has been is they have at any given time about 200 to 220 agricultural projects going on, and they've got a lot of difficulty sharing data between projects. And so they've tried several times to build systems to share information, and that's where we come in, is to try to help bring all these different data sets from many different projects together so that they can be shared and also even be able to compare the data between them and all that. Our system is it's a cloud-based SaaS, which means software as a service system. And what that means is the application and the data lives in the cloud. So wherever you are, you have access to your data. So if you are right here and you want to access your data, you can reach it. If you're on a laptop at home, you can reach the data. If you're out in the field with a tablet or a laptop computer out in the field, as soon as you get access to the internet, you can access that data. So if you can load something out in the field and come back and on your desktop be able to see it immediately. So it's a cloud-based system for both the application and the data, which means you've got worldwide availability of that information and the application. Now, a lot of people think, well, if it's cloud-based and everything's going to this one big database, what about security? How secure is my data from other people having access to it? And of course, our system is designed for sharing information, but it's all permission-based security on every data set, which means you select who can actually access your data. So many of you I know are scientists that you want to be able to put your data in a place that you can access and maybe some colleagues can access, but no one else, for maybe a year to give yourself time to do your analysis, prepare your papers, publish papers, and then release the information to other people. So you can have full control over who has access to your data. And as Dalit mentioned, we want him to, any of you that are partners of ICRISAT, we're going to allow them to extend some licenses to any of you that would like to try the system. And once again, you can upload your data and you have permissions as you can either allow that data to be shared with ICRISAT or just keep it for yourself and only you can access that information until you choose. So a lot of capabilities to keep it secure. And then also the cloud-based system, it enables us to do ongoing development. In other words, basically every couple of months we do updates to the system, add new functionality, new capabilities. And if you log in today, you'll have today's version. And if we do an update tonight, when you log in tomorrow, you'll have new capabilities and new features. So we'll be doing ongoing, and everyone has access to that immediately with new updates. So it's pretty powerful having this cloud-based type system. So what it is, the objective of a platform like this is to be a data repository for sharing curated data. So the idea being that you get data sets, curate them, massage them, clean them up, and then you're able to then share those with other people. And it can be just individual collaborators or colleagues, or open up the whole areas, or open up to the public to actually have access to the information. And the things we already have in the system, we have some public data sets. So for example, a lot of information from World Bank, FAO, World Health Organization, Harvest Choice. There's quite a few publicly available data sets that we've already incorporated into the system so that you have access to. Now any of these data sets are all publicly available. You can go online and access that data. However, when you go there, they've each got their own little quirks as far as the way they're organized, the format you download, and very often you'll have forms. So what's the average temperature for this day for the last 10 years to see what the normal values are for temperature and all. So a lot of information available, and this is all freely available to you now, and Chuka and all can help you get access to this immediately and start using it. So the objective of our system is, one, being able to access multiple sources. So the idea of bridging format differences. So I can bring different data sets that are in different formats and get them all together in one location. And also bridging geographic and temporal resolution differences. I think all of you have probably had the experience of having survey data that's at a household farm level. Also having data that was maybe aggregated and came to you at a village level, or came in at a district, state, or even a national level. And how do you compare those? How do you compare farmer surveys that are individual locations to some state or national level statistics to see how they compare? That's what our system is very good at, is being able to bring in these household level information, say 1,000 or 2,000 farmer surveys, and then aggregating it up to the district level, to state level, and national. Now in the future, one of the things we're trying to get a little project going with the Gates Foundation is to build up a better database of village locations. That's very difficult. So we can actually take the farmer information and aggregate it up through villages and be able to bring village data in and compare it. But it's a difficult project because, one, a lot of villages, in Africa and Asia, and also many, many, many different spellings, of these things. We're trying to work on some technology to be able to locate villages. And also, in addition to this household, gridded data. So that's like the weather data we have in satellite derived, where we have 2-minute, 5-minute, 10-minute gridded data to be able to also aggregate and bring that in to compare it. And then also, a key thing, and I'm going to show you a little example, is some built-in statistics to understand your aggregation comparability. What that means is, if you take survey level data, and say 2,000 farmer surveys, and aggregate that up, say, to the district level. Now, I think some of you later you're going to have a lecture by Abhishek talking about curated data. And he said, and one of the things he says is what you all know, garbage in, garbage out. Well, I maintain that garbage in a computer system like this, garbage in is worse than garbage out because it looks right. It looks good. When you put numbers on a spreadsheet, all of a sudden it must be right. It's printed in the computer. So it makes things that may not be good look good, and it can be very deceiving. So one of the things that we've done, and this is something we've learned from ICRISAT and we've implemented in the system, is as we aggregate up, we have statistics to show you, for example, I might be able to look at data on a per district basis, and I see the yield is 1,500 kilograms per hectare in this district, 1,700 here, 1,650 here, 4,000 kilograms per hectare in one particular area. Now, is that a very, very high yield area? Some very, very good smart farmers. But if I look at the statistics, I might find that I had 150 farmers here, 225 here, 330 here, one farmer in this district. So maybe my statistics aren't so good. So we allow you to see those statistics of the aggregation so that you know if you can trust that number. I'll show you an example in just a moment. And then basically it's what we call direct and contextual data. So for example, if your job is to go out and collect information at trial locations or at a farmer's sites and collect that information there, that's your direct information. And you can bring it into the system and then bring in weather data, FAO data, World Bank, other data that is gives you context that understand, well, how does my survey of my 1,000 farmers compare to what FAO measured over the last couple of years at a national level? Are we in the same ballpark here or not? Or do I have some exceptional farmers in my area? And another thing we can do is build what we call multi-dimensional risk investment indices. What that means is we can take multiple variables across a geography and then create an index. So for example, and that index could be to help figure out an investment strategy, or it could be to figure out an intervention strategy. So you might say, we're trying to introduce a new variety, and what we want to do is let's build an index that has let's look at look for low nutrition levels in an area. Let's look for low yields, but maybe high education and good gender equality. So maybe my donor wants to only support areas that have good gender equality. So high gender equality, high education, but low nutrition, low yields. And so we'll see we build an index of those four variables, and we'll see a map that shows the areas that have the highest combination of those. That might be my place. It's the first place I want to try an intervention. That needs it, and maybe has some education that can get better adoption for a first time. So being able to create these multidimensional indices. So the other thing, basically sharing, being able to share these complete analysis. You can pull together multiple variables into an analysis that you look at. Then you can share that information. If there's anyone else who has a license or a system, you just put their name in, and then the next time they log in, they'll see the analysis you did. They'll have the data set you put together and the graphs you've plotted, but not just the plots. They'll actually see the data behind it, so they can actually challenge your assertions and challenge what your observations that you've made to see if they agree with it or not. And the other thing we can do is that we have the notion of publishing, which means you create a web link presentations for indirect users. So someone who does not have access to our system, but maybe you want to be able to publish a graph that shows the adoption rates of a variety you're working with, and you want the public to be able to see that, or you want your donors to be able to see that. You can take that plot, get it the way you like it, and then create a link, and it creates an automatic web page that anyone can access that you send an email to with that link. We can export information to Excel so that you can still take it into other systems and do other things with that data. That's one of the ideas of sharing. If you can access data that someone else has collected, and you can use it in our system, or you can just export it out into Excel and bring it into whatever system you're doing. And also, we have some lightweight analysis tools. They can do some geographic and temporal aggregation, some calculated variables, these multiple attribute indices. And so basically, the way we like to say it is, what the platform is and is not good for, what it is good for, is a place for analyzed, summarized surveys, trial summaries. So basically trial summaries with to allow broad access to them, and then general data to be shared across projects in the public. But what we're not intending our system for is raw, uncurated surveys. You can load them, but we think it's more appropriate to, if you've done some analysis and cleanup before you bring it into the system, to share it. Also, we have some lightweight analysis. We're not trying to compete with a SAS or Stata or other heavy statistics tool. Rather, we make it very easy for you to get data out of the system if you want to use SAS or Stata to do other statistics with it. And then we're not intending the system to do genotype analysis or detailed trial management. There are other systems you all use for trial management. But what we're trying to do is be able to be a place that you can publish some of your trial summaries that other people can access. It's not as technical as the outputs you have from your larger systems like that. So with that, I just want to give you a couple of quick pictures of what it looks like, and I'll finish here. So when you log into our system, we have a little thing called our Start Pallet, you'll see, which is the key things to get started. Make a new analysis, browse the library for existing data. I want to import my own spreadsheet. I want to take a look at some weather information. Here's the most recent analyses I've been working with. If there's anything that someone else shared with me, I'd see it right here in my shared. So if I shared something with you, when you log in, you'd see the analysis that I just published for you to be able to access it, and some help information and stuff. And then once you say click on, I want to browse the library, so this library shows up. And so for example, for ICRISAT, for any employee at ICRISAT that has access to the system would see these. They'd see the Hope Africa baseline survey, Hope Trials, TL2 Chickpea, TL2 Ethiopia, Malawi. It goes on. There's about a dozen or so databases that they've collected that are in the system already. And you'll be able to see the name of it, a quick summary of the information, what type of data is it. This is a data set. This is a survey. This is trials data. What's a link that tells me more information about this data set? When was it added? What geography does it cover? What time span? So a lot of brief metadata information. And if I pick one of those and click on it, then I'll see more information, the detailed description, maybe the methodology that was used to collect that information to describe it. Any kind of data policies are down here, and sharing policies. And then you can actually see all the actual individual questions or the data that's contained in it. And you don't have to import the entire data set. Many of these baseline surveys are, hundreds and hundreds of questions. And so you can just go in and pick out, for example, the average yield harvest and pull out 4 variables: the best average grain for Kharif, Rabi, and the average grain for Kharif and Rabi season. Grab those 4 and then hit the Add to Pallet button. Boom, it drops in what we call the pallet, which is the place you drop your data to observe it. And once I've dropped it in, I can also, instead of the library, which has all my data that's available, dozens and dozens of databases potentially, you can also have a little loader that lets you just take any spreadsheet and upload that data yourself. And so all you do is just say, I want to import. We bring up a little 4-step process there. And what you do is you open up a spreadsheet. So it's just like in Excel when you load it, but you'll see a copy of the spreadsheet. So here's some World Bank data that had countries, several different years, and then machine counts, land area, cereal yields, forest areas, so quite a few variables at a national level over several years. And what you do is you just make sure you identify what row is the header row, and where does the data start. And then it flips over and shows you all the columns, and it lets you put in some brief metadata to describe the types of information and the units. And we look at the names and try to guess them for you. So if we see the word country, then we'll know that that's a primary geography and it's a country for units. If we see the word year, we're going to say, okay, that's a primary date, it's a year. Excuse me. If we see the word area, we know it's an area. Probably we'll guess at whatever the units of area are, and you can correct it. See the word population. So we try to guess what they are based on your names. If you're a little bit smart about using good naming convention, we automatically can assign a lot of things and get it close to what you want to do to make it quick to bring in a spreadsheet. And then once again, I define them all like that, and I just hit that Add to Pallet button, and then boom, that data shows up in my little pallet, and then there's that machinery, land area, cereal land. It all shows up here, and then anything I check off goes into my table. And we have what we call so basically we're taking information out of this pallet and then showing it, we call our triple view, which is I see anything I check off, I see a table version of it. So I see here I'm looking at countries, a range of years, and the columns of data. I see a map, a map of the information, and I see a chart that shows some graphical representation of that information down here. And then what we do is we make it very easy to aggregate and group the data. So I'm here in the case, I'm just clicking on the geography column and say I want to group by geography at the country level. And what we do is we show you a summary, because all this data has 3 dimensions. There's the geography, there's the time dimension, and then there's the actual attributes themselves. There's 3 dimensions of data. I can aggregate on any one of those axes. But the problem is, in a table, I'm only showing you 2 axes. So we're hiding one from you. So in this case, I'm showing you the locations, each country, and I'm showing you the attributes for each country, but I'm hiding the years. That's the 3rd dimension. So what we're doing is showing you a summary that right now we're showing that we're averaging for each one of these. There's a range. I got 2007 to 2011, and there's 5 different years of information being aggregated together. So it's very easy to see what the statistics are behind. Because sometimes what we'll find in national data like this is maybe Burkina Faso, Cote d'Ivoire, and Ghana, I've got 5 years of data, but maybe Mali only have, there's 1 year, 2010. So it would show right here, I just see 2010 and only 1 year, so I would know a little bit more about how to compare these. Now I can also go and click on time, and there's a filter will pop out. I can just say, just show me 2010, just show me 2000. I can filter one specific year and just look at that 1 year here. And of course here I'm looking at the countries. I'm seeing the value of each of those variables. I just click and go through each one of those and see them mapped. So I see Mali has the highest crop production index right here. I also see a graph here. It shows there's my crop production index, there's my food production, and livestock for each of those countries here. Then I can also click on the time column and say group by time. So now I'm flipping it out the other axis. I'm seeing my time, 2007, 8, 9, 10, 11. And then I see what geography is aggregated. I've got 5 countries aggregated, 1 country each. And there's the values, by time. So now I'm seeing a time series, for each of these indexes to see how they've changed over time. And all I have to do is I see some basic statistics here, and then if I just take my cursor and hover it over any one of these, a little pop-up will show me, well, how many countries are actually included in that piece of data. So I can, again, compare to see what my statistics are for each one. And also in the attributes that are over here, if I hover my cursor over it, a little thing will pop up to tell me what the name is, what the units are, where did it come from, because I can bring data from multiple data sets. I can share it with you, and when you look, you can hover over it and see which data set each one of those came out of, so you know what the source is for each one. Because once again, once I've put this into one sheet, it's very difficult to understand where did this data come from, so we keep that documented with it. And the last thing I'll show you, there's also a little ribbon bar at the top. That's where all my commands are. So I can go up here and just click on File to open up new things and save things. I can download. I can copy the table and paste it into Excel. I can also go up here and hit my Calculate button and create my indices and do other things with it there. So that's kind of a high-level view of this platform. We try to make it easy to get data quickly into the system, bring other data in to compare it. It's very good at being able to aggregate from farmer level up to districts, up to countries, and be able to compare these data sets or different aggregations. And then we make it very easy for you to publish it. Share it with other colleagues that have access to the system, or just publish links, HTML pages you can share with the public or anyone else there and all that. So that's my speech. And if you have any questions, I'd love to have it. And also through Chuka, you can also have my email if you have any questions, or Chuka is an expert in this system, so he can answer most questions too. But thank you very much for your time. Thank you for letting me get in front of you. And I hope I'll see you other times, and come visit me in Colorado sometime. When it's warmer. Yeah.
Interesting way of using the data. I'm sure some of you have expressed that how to manage the data. Especially they were telling, one of the participants has expressed that how to use the genomic data.
Mm-hmm. Well, for us,
one of the participants, I don't know who is that, but one of the gentlemen has expressed that his expectation from this workshop is to know how to use the genomic data. Perhaps you can, you can interact with Dr. Pollock, and then perhaps with.
Yeah, we'd love to work with you there, because one of the things we see there is, again, the idea is to be able to bring in some summaries of information that you have, some summary information of some trial results you've had, from different varieties and what locations they were at. And then we make it very easy to go out and pull, like you can take trials from 2 years ago, and you tell us what the season, well, automatically you can pull up what the weather was at that location at that time, so that you can associate. So if you had good yields here, bad yields here, was it because of bad variety, an unmatched, it wasn't matched to geography, or did it just not rain that year? So you can help. The causality is a big thing that we do with our system, is looking for what is the cause of this change. Is it because of the variety, or is it because of bad geography? And the other thing we're working on for the future is targeting. So if here's a set of conditions that I need. I want never have a maximum temperature above this, never have a minimum temperature below that. I need to have this much precipitation during the first third of my season or whatever. You can put those parameters in, and we can show you, here's all the places that match that for the last 10 years. Or we can just say, just look at the last, because of climate change, just look at this the last 3 years or 5 years. What areas have those characteristics, do matching and all that. Those are things we think can help with that.
Yeah,
We have a lot of the raw data so that you can do that, and that is something that being able to do regression and direct correlation like that, that's something we have on our roadmap for the future. But right now we'll give you the raw data that you can do it, like in SAS or stat or something. But some of those simple, or not simple, but some of those things that are common like that, those are the kind of simple analyses. We want to make it simple for you to be able to do that right in the system. Just to say, okay, here's 4 or 5 variables associated with 4 or 5 yields, and now do some correlation across those to see if there's any causality, so regression. So that's some of those things are things we want to make it easy for you to hear, which is a little bit more difficult, but can be done certainly in Stata or SAS or the system. Okay, well, thank you again very much for your time and your attention.
well, actually, we all like to join you in appreciating Dr. Pollock for his sharing this information to you. And then in usual way, we'll appreciate it.
Ah.